UGC NET Electronic Science January 2025 question paper solutions part 3, that is from question number 1012 to question number 125. Let us see the first question, that is question number 101. For a stack pointer in 8051, the stack is a section of RAM used by the CPU to store information temporarily. The registers used to access the stack is called stack pointer. The stack pointer in 8051 is of 8-bit wide and can take the values from 00 to FFH. When 8051 is powered up, the stack pointer contains a value 07H, that is, the stack starts at memory location 08H. The stack pointer can point to any location in the internal RAM, including addresses from 0 to 127. The stack pointer's initial value determines the position where stack starts. So let us see the statements in the given question. It is a 8-bit wide register. So stack pointer in 8051 is a 8-bit wide register. Statement A is correct. It is a 16-bit wide register. Statement B is wrong. Next, statement C. When a chip is reset, the register is initialized to 07H. Statement C is correct. And statement D is wrong. The pointer can point any location of internal data RAM from 0 to 127. Statement E is correct. In the given question, statement A, statement C and statement E are correct. A, C, E. The correct option is 4. Next question. A platinum thermometer has a resistance of 100 ohm or 25 degrees centigrade. Given the temperature coefficient of resistance for platinum is 0.004 per degree centigrade, taking linear approximation, find the temperature at which the resistance will be 150 ohms. So the resistance at temperature T is given by RT is equal to R0 into 1 plus alpha delta T, where delta T is change in temperature, alpha is the temperature coefficient of resistance. And this formula is for linear approximation. This formula is obtained after linear approximation. So resistance at temperature T. So given RT is 150 ohm and R0, resistance at 25 degrees centigrade is 100 ohm. Here delta T is change in temperature. So temperature T2 minus T1. So initial temperature is 25 degree centigrade. Initial temperature is T1 25 degree centigrade. And the given alpha is 0.004 per degree centigrade. So substitute the values in the given formula. In the above formula, RT is 150 ohm, R0 is 100 ohm into 1 plus alpha value is 0.004 delta T is T2 minus T1, T2 minus T1 is 25 degree centigrade. On substitution, the value of T2 will result 150 degree centigrade. So correct option is 1. Next question. When a MOSFET is operating in saturation region, so MOSFET operating in saturation region with VD greater than VD saturation, then transconductance is. So we know that the drain current ID is mu n COX by 2 W by L VGS minus VTH whole square, where mu n is electron mobility, COX is oxide capacitance per unit area, W is a channel width, L is a channel length, VGS is gate source voltage and VTH is threshold voltage. Now the drain conductance, transconductance GM is dou ID by, so transconductance GM is, so differentiation of drain current with respect to gate source voltage, dou ID by dou VGS. On substitution, we will get transconductance GM is mu n cox w by l vgs minus vth. Now substitute. We know drain current id is half mu n oxide capacitance cox w by l vgs minus vth, vgs minus vth. So that is vgs minus vth whole square, and the transconductance gm is mu n cox w by l vgs minus vth. Substitute this mu n cox w by l as gm in the equation 1. Let us suppose gm as equation 2. Now drain current id is half gm into vgs minus vth. Now transconductance gm is 2 id divided by vgs minus vth. So that is correct option is 4. Next question. Arrange the settling time in descending order of the following types of second order systems having undamped natural frequency omega n. So we know that for a overdamped case, damping ratio zeta is greater than 1. For underdamped case, damping ratio it exists between 0 less than zeta less than 1. For a critically damped, zeta value is 1. For undamped case, zeta is 0. Damping ratio is 0. We know the settling time Ts is 4 by zeta omega n for 2% tolerance band, and settling time Ts is 3 by zeta omega n for 5% tolerance band. Settling time is inversely proportional to zeta. Now for undamped case, for undamped system, zeta is 0. If zeta is 0, settling time tends to, or settling time is infinity. For undamped system, settling time is infinity. So settling time is highest for undamped system, that is D. So here it is highest, settling time is highest. For overdamped system, for overdamped system, zeta value is greater than 1, therefore settling time is least. Settling time is, it is less than 1, which is a least value. Which is a least value. Therefore, in the decreasing order, highest is for undamped system and lowest is for overdamped case. So undamped system followed by underdamped and then critically damped. So that is D, C, B, A. In the question, arrange the settling time in increasing order. Suppose in the question, increasing order is mentioned, then option 3 is correct. In the question, descending order is mentioned, descending order of settling times, therefore correct option is 1. Next question. An air-filled parallel plate capacitor is made up of circular discs having an area of 2 meter square. The spacing between the disc is 0.1 meter. If the voltage applied is 20 into 1000 T across the plates, find the displacement current density. We know that current I is equal to C dV by dt. Current flowing through the capacitor is C dV by dt. The capacitance C is epsilon naught A by d dV by dt. So current density is current per unit area. So current density is current per unit area. Therefore, displacement current density JD is epsilon by d dv by dt ampere per meter square, where V is the voltage applied across the plates. The applied voltage is 2 into 10 cube T. D is the spacing between the disc. The spacing value given is 0.1 meter. A is the area of the disc. Disc area is 2 meter square. Now substitute the given values in displacement current density formula, that is epsilon. Here air field, it is an air filled capacitor, so relative permittivity is 1. Epsilon naught value is 8.854 into 10 power minus 12 farad per meter. So JD is 8.854 10 power minus 12. Epsilon R value is 1 divided by distance 0.1 into dV by dt. So voltage d by dt of voltage V, that is d by dt of given voltage is 20 cos 10 cube T. Its value is 20 into 10 cube. D by dx of cos is sine 10 cube T. So that is 20 into 10 cube sine 10 cube T. So on substitution, its value is 2 into 10 power 5 sine 10 cube T. 2 into 10 power 5 sine 10 cube T. It is an air filled capacitor. We can take epsilon naught value as 1. So correct option is 2. Next question. Arrange the region of convergence if the sequence is. So different sequences are given and the region of convergences are. This region of convergence of a jet transform is a circular disc or a ring in a jet plane centered at the origin. Region of convergence of jet transform. For jet transform, ROC does not contain any poles. For a jet transform, the ROC of LTI stable system contains unit circle. LTI stable system ROC contains unit circle. ROC of jet transform must be a connected region. If x of n is delta of n impulse sequence, only impulse sequence, ROC of jet transform is entire jet plane. If x of n is infinite duration causal sequence, ROC is margin greater than a, that is exterior of the circle. If ROC is infinite duration anti-causal sequence, ROC is interior of the circle of radius b. If x of n is infinite duration two-sided sequence, then ROC is a ring in a jet plane bounded by A and B, that is interior and exterior by a pole, but does not contain any poles. ROC does not contain any pole. If ROC is, so if the sequence is finite duration causal sequence, that is right-handed sequence, ROC is entire jet plane except at z is equal to 0. If x of n is finite duration anti-causal sequence, ROC is entire jet plane except at z is equal to infinity. If x of n is finite duration two-sided sequence, ROC is entire jet plane except at z is equal to 0 and z is equal to infinity. The ROC of sum of two or more sequences is equal to intersection of ROCs of these sequences. So this is a complete picture of region of convergence for a sequences in Z transform. Now for causal and finite sequence, ROC is entire jet plane except at Z is equal to 0. For causal and infinite sequence, for causal and for anti-causal and finite sequence, ROC is entire jet plane except at Z is equal to infinity. So A is A, B is D. For causal and infinite sequence, ROC is outside of the radius R. For anti-causal and infinite sequence, ROC is inside the radius R. Correct option is 3. A small b match to D, C match to capital B, and small d match to capital C. Correct option is 3. Next question. Inverse Fourier transform of delta of omega minus omega naught is. We know that Fourier transform of 1 is 2 pi delta of omega. Fourier transform of 1 into e power j omega naught is 2 pi delta of omega minus omega naught. And inverse Fourier transform of delta of omega is 1 by 2 pi. Inverse Fourier transform of delta of omega minus omega naught is 1 by 2 pi e power minus j omega naught. Correct option is 4. 1 by 2 pi 1 by 2 pi e power j omega naught. Correct option is 4. Next question. At 300 Kelvin, the molecular diameter of oxygen is 3.64 Armstrong and the number of molecules per unit area Ns and pressure value is given below. Arrange the time to form one monolayer in increasing order. So time to form a one monolayer in increasing order. So let us see the formula. The time to form a monolayer of a gas molecule on the surface is T is equal to Z by S. Here Z value is not given, sticking coefficient is not given, so sticking coefficient is assumed to be in the question. Sticking coefficient is not given, sticking coefficient is assumed to be unity. And T is the time to form a monolayer, Z is oscillation frequency. And the expression for Z in terms of pressure and temperature is Z is equal to P square root of 2 pi m by kT. So this Z is inversely directly proportional to temperature and inversely proportional to square root of temperature. So we can write, and the collision frequency Z is given by Z is equal to 0.25 into n nu bar, where nu is n into v bar, where v bar is average molecular speed and n is the number of molecules per unit volume. Therefore, from the above these three expressions, we can write this time to form a monolayer T is directly proportional to Ns and inversely proportional to pressure. Therefore, for option A, T is equal to 2.64, T is equal to some constant into 2.64 into 10 power 14 by 1. Pressure is 1 Pascal. Its value is K into 2.64 into 10 power 14. For option B, T is equal to constant K into 5.28 10 power 14. Pressure is 10 power minus 1, that is 0.1. 52.8 constant K into 52.8 into 10 power 14. For option C, time to form a one monolayer is some constant K into 2.64 10 power 14 divided by 10 power minus 8. Its value is some constant K into 2.64 into 10 power 8 into 10 power 14. For option D, time T is equal to some constant K into 7.92 10 power 14 divided by 1. So that is K into 7.92 10 power 14. In the question it has been asked increasing order. So increasing order, option C is the highest one. Highest time and lowest time is for option A, 2.64 into 10 power 14. Option A it is lowest, option C it is highest, and then followed by D 7.92, and for B it is 52.8 into 10 power 14. So correct option is 2. A, D, B, C. Next question. Consider a silicon control rectifier, that is a thyristor structure shown below. This silicon control rectifier has SCR has 4 layers, 3 junctions, and then 3 terminals. And the modes of operation in SCR are forward blocking mode, forward conducting mode, and reverse blocking mode. In forward blocking mode, junction J1, J3 are forward bias and junction J2 is reverse bias. When gate is triggered in this mode, in forward blocking mode, when gate is triggered, it becomes forward conducting mode, that is all the 3 junctions are in forward bias, enabling silicon control rectifier to conduct the current. In reverse blocking mode, junction J2 is forward bias, J1, J3 are reverse bias, effectively turning the silicon control rectifier. This is complete off state and this is complete on state. In the given options, for complete on, all the junctions should be forward bias. For complete off state, J1 is reverse bias, J3 is reverse bias, and J2 should be forward bias. Therefore, correct option is here. None of the options are correct, so we can take the relevant answer. J1 forward blocking, that is J1 is forward bias, J3 is forward bias, and J2 is reverse bias. Next question. Arrange the free running frequency of phase lock loop in descending order. So we know that if a phase lock loop for analog PLL, it is free running frequency or center frequency is given by 1 by 2 pi square root of LC. For digital phase lock loop, the free running frequency is given as 0.16 into supply voltage VDD divided by R1 into C. R1 is a external resistor, C is the external capacitor. So let us assume this is a given, the given PLL is digital phase lock loop. So 0.16 VDD by R1 into C. So therefore the free running frequency is the inversely proportional to this free running frequency is inversely proportional to 1 by R1 into C. So that is free running frequency is K by R1 into C. K by R1 into C. From option A, R1 into C value is 12 microsecond. For option B, it is 5 microsecond. 5 microsecond. For option C, 200 microsecond. For option D, it is 150 nanoseconds. Therefore, the time constant is lowest for option D. So time constant is lowest here and highest is for option C. So time constant is D less than, B less than, A less than C, and the frequency is inversely proportional to time constant. Therefore, D greater than, B greater than, A greater than C. The frequency is lowest for option C. Frequency low, frequency is high for option D. In the question, they have asked decreasing order. So decreasing order of free running frequency. So decreasing order of free running frequency is D greater than, B greater than, A greater than C. The correct option is 3. Next question. So SCM, XRD, TEM, EDS is given. Let us see some key points related to this. SCM stands for scanning electron microscopy. The scanning electron microscopy, it is used to study the surface morphology of thin films. SEM is a non-invasive technique focused on high energy electrons to examine the surface of a material or morphology of thin films. Next, XRD. It is a technique. XRD is a technique used to study the crystalline properties of materials, including their structure, phase, orientation. It is also a non-destructive method. So TEM, transmission electron microscopy, uses beam of electrons to create magnified images of thin films. EDS, energy dispersive X-ray spectrography, it is a technique used to analyze the chemical composition of materials, used to study the chemical composition of materials. Let us see list 1 and list 2 matching here. So this SEM, it is used to study the morphology of thin films. XRD, XRD used to study the crystalline properties, and TEM uses transmitted electrons passed through thin sample films. EDS used to study the chemical composition of materials. So correct option is A2, B1, C3, D4. So that is correct option is 2. So SEM, scanning electron microscopy, used to study the surface morphology of thin films. X-ray diffraction, XRD, used to study the crystalline properties of materials. TEM, transmission electron microscopy, uses transmitted electrons passed through thin sample films. EDS, energy dispersive X-ray spectrography, used to study the chemical composition of materials. Next question. So it is related to 74LS inputs driven by 74HC output. So this 74LS is low power Schottky transistor logic. 74HC is high speed low power IC that uses CMOS technology. So the number of to calculate the output of 74HC can drive the number of 74LS inputs. The first step is calculate the high state fan out, and next calculate low state fan out. Calculate both high state and low state fan out and pick a smaller of the two values, which gives the number of 74LS inputs driven by the output of 74HC. So high state fan out is IOH of HC. IOH of HC is 4 milliamperes, 4 into 10 power minus 3, and high state fan out in 74LS, that is 20 microampere. 4 and 20 microampere. Its value is 20. And for low state fan out, so IOL HC, so that is 4 milliampere. 4 milliampere divided by 0.4 milliampere. Its value is 10. So the minimum of these two. So minimum of 20 comma 10. So that is 10. So the output of 74HC IC can drive 10 74LS inputs. The correct option is 4. Next question. 3 windows in case of optical fibers used for communication is. So general windows used in optical communication are: the first window is at 850 nanometer, second window at 1310 nanometer, third window at 1550 nanometer, and fourth and fifth windows also 1625 nanometer and 2060 to 1360 nanometers. Generally, the first three windows 850, 1310, 1550 nanometers. So that is 850 nanometer, 1310 nanometer, 1550 nanometers. Correct options are A, B, and E. So correct option is 4. Next question. So it is related to the IC name and its numbering. IC 8251 is 8251 is universal synchronous asynchronous receiver and transmitter, that is USART. 8259, it is also known as programmable interrupt controller. 8279, It's a programmable keyboard or display controller designed by Intel that interfaces keyboard with the CPU. 8253 and 8254 are timers. Programmable interval timers. Let us see the matching list 1 and list 2. Programmable interrupt controller, that is 8259. 8259. USA RT 8251. And then keyboard or display controller 8279. Programmable internal timer, that is 8254. Correct option is A4, B3, C2, D1, that is option 4. Next question. It is related to noise figure of a system. So the noise figure of two-stage cascaded amplifier is calculated by using the Friis formula. Noise figure total is F1 plus F2 minus 1 by G1, where F1 is a noise figure of first stage linear value, F2 is a noise figure of second stage linear value, G1 is a gain of the first stage. Then overall noise figure, total noise figure F is equal to F1 plus F2 minus 1 by G1. To convert linear into decimal value, take 10 log of 10. So here, so the noise figure of individual stages are 2.03 and 1.54. F1 and F2 is given. The available power gain of the first stage is G1. Its value is 62. So G1 is 62. Then overall noise figure of the system is F is equal to F1 plus F2 minus 1 by G1. Substitute the given values. 2.03, F1 is 2.03, F2 is 1.54 minus 1 divided by 62. So its value is 2.0387, approximately 2.04. So nearest option is 2.05. Then in terms of logarithmic scale, 10 log of linear value, that is 2.0387, 2.8307. Its value is 3.093 dB, approximately 3.10 dB. Here the correct option is 2. Only linear value is asked. Next, for a super heterodyne receiver. So let us compare this super heterodyne receiver with tuned radio frequency receiver. The selectivity is high for super heterodyne receiver, sensitivity is high, stability is very good, image frequency rejection is good, whereas image frequency rejection is poor for tuned radio frequency receiver. The basic principle of super heterodyne receiver is it converts the incoming radio signal or radio frequency signal into a fixed intermediate frequency. In case of TRF, directly amplifies the incoming signal. So broad range of frequency coverage in super heterodyne receiver. Audio quality is better, good audio quality, and the cost is slightly higher. In super heterodyne receiver, the mixer generates some and different frequencies. Statement A is correct. The local oscillator frequency is smaller than carrier frequency. So this statement is wrong. So generally, the local oscillator frequency is greater than incoming signal frequency, that is radio frequency signal. If local oscillator frequency is greater than radio frequency signal or incoming signal frequency, then better image rejection is possible and it is easier to design fixed intermediate filters, IF filters. Statement B is wrong. Statement C, the IF signal is amplified in an intermediate frequency amplifier. Statement C is correct. Selectivity is poorer than TRF receiver. For super heterodyne receiver, selectivity, sensitivity and stability is good. So statement D is wrong. It is not poorer, it is better. So option A and option C are correct. Sorry, statement A and statement C are correct. Correct option is 4. Next question. The decoded output of 7445 decoder is connected to an LED as shown in the figure. If the resistance R is 1 kilo ohm and each LED has forward drop of 1.2 volts, what is the current? How much current is there through the LED when it is conducting? So the given circuit is decoder. So it can be simplified as like this, where the applied voltage VCC is 5 volts, resistance R is 1 kilo ohm, and applied voltage VCC is 5 volts, and this is a LED given represented by green light, and the output is Y of N. So we know that current through LED I, the current through LED is 5 minus voltage drop across LED, that is 1.2 volts by 1 kilo ohm. So its value is 3.8 milliampere. So correct option is 3.8 milliamperes. So given that LED is conducting, assuming the output voltage is 0. Next, different number systems are given. We need to find the equivalent values. For triple one, triple zero, base 2. So convert it into a decimal number. So its weight is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. 2 power 5 is 32, 16, 8, 40, 56. So it is 56 base 10. So its value is 56 base 10. So A3. A3. Next is take option D, 1 0, 1 0, 1 0. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. 2 power 5 is 32, 2 cube is 8, 2 power 1 is 2. That is 40, 42. 42 base 10. So its equivalent value is 42 base 10. For option D, it matches to 2. Next is take statement C, the list 1, 34.75 base 10. So convert this decimal number into binary number. So 34 by 2. 34 by 2 is 17. 0. 17 by 2. Its value is 8. Remainder is 1. 8 by 2. 0. Remainder is 0. Quotient is 4. 4 by 2 is 2. 0. 2 by 2 is 1. 0. So therefore this is MSB. For integer part, 1 0 0 0 1 0. For decimal part, 0.75 into 2. Its value is 1.50. Take 1, 0.50 into 2. Its value is 1.00. So take this 1, 0.00 into 2. See, it is 0 0. That is 110 base 2. So 34.75 can be written as 100010110 base 2. So correct option is, for C it is 1. So obviously for B it is, the remaining one is 4. So correct answer is A3, B4, C1, D2. So option 4 is a correct answer. Next question. For a gun diode, different statements are given. We need to identify the correct statements. Before that, let us see some theory related to gun diode. So gun diodes are fabricated using These gun diodes are fabricated using compounded semiconductors such as gallium arsenide, indium phosphide, indium arsenide. It is a group of third and fifth group elements. So gun diode operates as a bulk device based on gun effect, which arises from negative differential resistance in certain materials. It is a transferred electronic device that uses negative differential resistance of uniform semiconductor to amplify and oscillate microwaves. Next is hot electrons or electrons that have gained a lot of energy from a specified electric field and have higher kinetic energy than those in the thermal equilibrium. So hot electrons have gained lot of energy from the applied electric field and have higher kinetic energies than those electrons at thermal equilibrium. So gun diode is made up of n-type semiconductors like gallium arsenide, multi-valley band structure. At low fields, electrons stay in central valley where they can move easily. That means at low fields, electrons stay in central valley and have high mobility. At high electric fields, electron higher jumps into a higher energy satellite valley with low electron mobility. At low field, high electron mobility. At high field, lower electron mobility. So this causes a negative differential resistance. This movement of hot electrons between the valleys what causes the oscillations. This is a theory related to gun diode. So let us see the question now. For a gun diode, fabrication is performed using elemental semiconductors. So this option is statement A is wrong. It is performed by using compounded semiconductors. So the device operates with hot electrons. Statement B is correct. The amplification and oscillations are derived from bulk negative resistance property of semiconductors. Statement C is correct. It operates either with junctions or gates. Statement D is wrong because gun diode has zero junctions. So this gun diode has no junctions or zero junctions. So correct answer is B and C statements are correct. Correct option is 1. Next question. A cellular system. This question is drop. So let us see the question here. A cellular system has 12 macro cells with 10 channels per cell. The macro cells are split into 3 micro cells. Determine the number of channels available for system for splitting into picocells. In the question, it is not mentioned each microcell is splitted into how many picocells. Hence, this question is dropped. Given 12 macro channels, 10 channels per macro cell. Therefore, total number of cells in the original system is 12 into 10. 12 into 10, that is 120 channels. Now splitting each macro cell into 3 micro cells, that is 12 into 3, that is 36 micro cells. The same number of 120 channels is reused more efficiently via cell splitting without adding the new channels. Again splitting microcell into picocells. Here number is not mentioned. The total picocells is not obtained. The total number of channels available in the system is 120. Cell splitting into smaller cells does not increase the total number of channels in the system. It increases the frequency reuse. So effective number of channels available per unit area increases but not the absolute count. So this is the conclusion point in the given question. Next question. The output Y shall be high, that is logic 1 for the given circuit. Different options are given. So here the Y is the gate connected to output is NOR gate. So take statement A. Take, take option 1. If S1 is open, S2 is open, then P. The AND gate 1, let us take this is AND gate 1, AND gate 2. So AND gate 1 output P is 1. If both are high, P is 1, Q is 0. For NOT gate, for 1 0, output Y is 0. So this is for option 1. For option 2, the output S1 S2 are open. So if S1 S2 are open, P is 1 and Q value is 1. So because A is high, the other output also high, Q is also 1. Therefore output Y is 0. Take option 3. So S1 is open, S1 is open, S1 open, S2 closed. Therefore AND gate output 1 0 is 0. Next A is low, S2 is closed, and A, the input connected to second AND gate, it is also low. If S2 is closed, switch S2 is closed, the input available is also low. Q is also 0. If both are 0, if P is 0 and Q is 0, the output Y is 1. If both are zeros, NOR output is 1. So correct option is 3. Similarly, for option 1, for option 4, it is also wrong. Correct option is 3. Next question. So it is between, generally CZ, FZ and Bridgman techniques are used for crystal growth. Which of the following is a correct answer? Let us see some points here. This FZ process used to grow silicon offers low contamination. FZ process offers low contamination, and CZ process involves melting the material in a quartz crucible which can introduce impurities, especially oxygen. FZ process does not use a crucible, instead it uses zone of melting material moved along with the solid rod. It greatly reduces contamination, making it preferable for ultra pure silicon. This FZ process is used for low contamination. It offers low contamination and it is preferred for ultra pure silicon. Next is gallium arsenide growth by CZ process requires B2O3 encapsulation to prevent arsenic evaporation, and Bridgman method usually uses graphite boards but not the quartz, because quartz can react at high temperatures used for gallium arsenide. Let us see the statements. FZ process used to grow silicon has higher contamination, so it is lower concentration. It is not concentration, it is low concentration as compared to CZ. Statement C is correct. In gallium arsenide, crystal growth, when grown by CZ technique, there is no need of B2O3 liquid. There is a requirement of B2O3 liquid. So statement 2 is also wrong. A quartz board, it is not quartz board, it is graphite board. A graphite board used to grow gallium arsenide by Bridgman system having two-zone furnace in a sealed tube of graphite. So correct answer is 3. So it is not high concentration and there is a need, it is not a quartz board. So correct option is 3. Correct statement is 3. Next question. A resistance R and 5 microfarad capacitor are connected in series with a 100 volts DC supply. Calculate the value of R such that voltage across the capacitor becomes 50 volts in 5 seconds after the circuit is switched on. So initially at the time of switching, the voltage across the capacitor is 0. The general formula for voltage across the capacitor is Vc of t is V final minus V initial e power minus t by tau. Since it is a RC series circuit, and the voltage across the capacitor is, initial voltage is 0 and the voltage across the capacitor is V final into 1 minus e power minus t by tau. Tau is a time constant where resistance R is not given in the circuit. We need to calculate the value of R, and the value of C capacitance is 5 microfarad. It is given. and the time it is mentioned is 5 seconds. So we need to calculate the value at 5 seconds. Time t is 5 seconds. Now voltage Vc of t at 5 seconds is 50 volts, 50 volts, and the final value is 100 volts, 1 minus e power minus t by, so the value of t is 5 seconds. Tau is RC into 5 micro 10 power minus 6 microfarad. On substitution, the value of R is 1.45 mega ohms. 1.45 mega ohms. Correct option is 3. Next question. A simplified Boolean equation for a given logic expression is given. Here minterms are given 7, 9, 10, 11, 12, 13, 14 and 15. So using K-map, arrange the minterms. These four mint and forms a pair. So here grouping, three quads are formed and single pair is formed. A pair can pair eliminate one variable, quad eliminates two variables, similarly octet eliminates three variables. So it is a four variable K map. In a quad, two variables are eliminated and it consists only two variables. And the given expression is, and the final resultant expression after simplification is, so this is AB plus AD plus AC plus BCD. So for this minterm it is AD, for this quad, for this group it is AC, minterm is AC, for this pair it is BCD. The final answer is simplified expression y is AB plus AD plus AC plus BCD. Correct option is 3. Next question. For a aluminum gallium arsenide heterojunction with doping 2 into 10 power 18 per centimeter cube and thickness of 40 nanometer. So given thickness of space layer is 40 nanometer, 40 nanometer, that is 40 into 10 power minus 9, and doping concentration is 2 into 10 power 2 into 10 power 18 per centimeter cube. So that is 2 into 10 power 18 into 10 power 6 per meter cube. The charge value is 1.6 into 10 power minus 19. Epsilon naught is 8.854 into 10 power minus 12. And epsilon r, the dielectric constant it has given in the question is, relative value of dielectric constant is 12.3. Substitute all the values in pinch of voltage. This formula, pinch of voltage Vp is QND by 2 epsilon into D square. So on substitution, pinch of voltage Vp is charge 1.6 into 10 power minus 19 and doping concentration is 2 into 10 power 24, 2 into 10 power 24, thickness is 40 nanometer, 10 power minus 9 whole square by 2 epsilon. Epsilon is epsilon naught into epsilon r is 12.3 and epsilon naught is 8.854 into 10 power minus 12. On substitution, after calculation, the value of this pinch of voltage is 2 point or 23.5 into 10 power minus 1, that is 2.35 volts. So correct option is 3, 2.35 volts.